Welcome to Daily Papers, the podcast where we break down one interesting research paper every day.
Today, we're talking about a topic that feels like it's straight out of a sci-fi movie, using super smart AI to fight online fraud and scams. We've all seen the headlines about large language models, or LLMs, the technology behind tools like ChatGPT.
And companies are getting very excited about using them for what they call trust and safety. That's basically the department that tries to keep the bad stuff off a platform. We're talking everything from credit card fraud and phishing scams to fake reviews and harmful content.
The idea is simple. What if an LLM could read a suspicious email or transaction and instantly tell you if it's a scam? It sounds amazing, but a new paper titled Operational Evidence Gaps for LLMs in Fraud Detection and Trust and Safety Workflows asks a really important question. Are these AIs actually ready for the job?
Right, it's one thing for an AI to perform well in a clean, predictable lab environment. It's another thing entirely to put it on the front lines of a live system, what the paper calls an operational workflow.
Exactly. Think of a real fraud detection system like an emergency room. Things have to happen fast, the stakes are high, and you can't afford to make mistakes. And most importantly, you have an adversary, a scammer who is actively trying to trick you and will change their tactics the moment you figure them out.
So the author of this paper did a deep dive. They looked at 49 different studies about using LLMs for fraud, content moderation, and similar tasks. And they found something they call an evidence imbalance, which is a polite way of saying there's a huge hole in the research.
A very huge hole. The paper finds that most studies are great at reporting a single number, like our model caught 95% of the fraud in our test dataset, but they often leave out the practical details you'd need to know before actually deploying it.
It's like a car company showing off a new engine that's incredibly powerful on a test track, but they don't tell you its fuel efficiency, its safety rating, or how much it costs to build. You'd never put that engine in a family car without knowing those things.
And the missing details for LLMs are just as critical. The paper points out a few big ones. First, there's latency. That's just a technical word for speed. If you're trying to block a fraudulent credit card payment, the AI can't take 10 seconds to think about it. The transaction will have already gone through.
The second is cost. These big AI models are expensive to run. If it costs a few cents every time the AI checks a message, and you have millions of messages a day, that bill is going to get very, very big. You have to know if it's worth the money.
And maybe the most important one is adversarial pressure. Fraudsters aren't static. The moment a new AI defender is in place, they'll be working to find its weaknesses. They'll change the wording of their scam emails, use clever new tricks. Most studies don't test how the AI holds up when it's actively being attacked by a clever human.
So here's the most surprising finding in the paper. The author compared the research on fraud detection with the research on content moderation, using AI to spot things like hate speech.
And it turns out the content moderation papers are doing a much better job. They are more likely to talk about things like cost, speed, and fairness. But when it comes to the fraud and scam detection papers, the evidence is shockingly thin.
Get this. Of the 18 core fraud and investigation papers the author surveyed, not a single one reported a clean per-decision cost in dollars or a clean per-decision latency. Zero. They just aren't reporting the most basic operational metrics.
Which is a bit of a bombshell. It suggests that while we're talking a big game about AI fighting fraud, we don't really have the public evidence to prove these systems are ready for prime time.
So does that mean we should just give up on the idea? Is it all hype?
Not at all. The paper doesn't say LLMs are useless, it just says we need to be smarter about how we use them. The author points towards what we could call a hybrid approach. Don't replace your whole system with one giant, expensive LLM.
Okay, so what does that look like?
Think of it like this. You can use older, faster, and cheaper automated systems to handle the 99% of cases that are either obviously fine or obviously fraudulent. They're like the first line of defense.
A bouncer who can quickly handle the easy calls.
Exactly. But for that tricky 1%, the cases that are ambiguous and need a closer look, that's when you call in the specialist. You escalate the hard cases to the powerful LLM. In this setup, the LLM isn't the whole security team, it's the expert detective you bring in for the tough nuts to crack.
Or it could act as an assistant to a human reviewer, summarizing a complex case or highlighting the most suspicious parts to save the human time.
Precisely. In these roles, the high cost and slower speed of an LLM might be perfectly acceptable because you're only using it when you really need its advanced reasoning abilities.
So, the key takeaway here is that when it comes to AI, especially in high stakes areas like trust and safety, we need to move beyond just asking, how accurate is it?
We have to ask the practical, operational questions. How fast is it? How much does it cost? How easily can it be fooled? And what happens when it makes a mistake? This paper is really a call for more realism in the field. It's pushing researchers and companies to not just show that their AI can work, but to provide the evidence that it does work in the messy, fast-paced, and adversarial reality of the real world. It's about building trust not just in the AI's intelligence, but in its ability to be a reliable and responsible part of a much bigger system.